The first thing that I want to talk about in this section is the Pythagorean Theorem, which should be something that's familiar to you. Okay? It's based on this relationship here in any right triangle, and that has to be a condition for this equation or this relationship to work. But in any right triangle, the sum of the squares of the two legs is equal to the square of the hypotenuse. Okay, so the sum of the squares of the two smaller sides in a right triangle are equal to the square of that longest side. Okay, the formula for it is a squared plus b squared equals c squared. So I'm sure you've worked with this before, whether you've specifically identified it or not. I'm pretty sure you've done calculations involving Pythagorean theorem. Okay, so let's kind of talk through how this process would work. So if you're given a right triangle and let's say the hypotenuse is your unknown, you could set it up in this form. Take the sum of the squares of the two legs. So in this case, 1 squared and 2 squared. Those have to add up to equal the square of the hypotenuse, which is our unknown. And so it's just a matter of solving. So simplify each of your expressions. So 1 and 4. Combine your terms. 4 plus 1 is 5 is equal to w squared. And then to solve for w, you do what's called extract the square root. When you extract the square root, you get w is equal to. Mathematically, you have to consider the positive and negative root, so this plus or minus square root of 5. However, because we're dealing with a length or distance here, it's impossible to have a negative value. So you can disregard the negative root, and your answer winds up being just the positive root 5. Okay. Right, let's jump over to this next one. And what if it's not the hypotenuse that's your unknown? What if it's one of the legs? Again, it's the same concept. You take the sum of the squares of the two legs. So 4 squared plus y squared is equal to the square of the hypotenuse. 5 squared, just plug in your values to the Pythagorean theorem. Expand each of your terms. Combine your like terms or isolate your variable. So here the y squared needs to be isolated. If we subtract 16 from both sides, we're left with 9. Extract the square root, and we get y is equal to, again, plus or minus the square root of 9, which is 3. You can disregard the negative since we're dealing with a length. And so your answer is 3. Now notice here, your answer could either be an irrational number, meaning it can have a square root in it, or it could be an integer. If all of your sides are integers, so in this case we have this 3, 4, and 5 are the sides of this triangle. There's a special name for those. We'll talk about them here in just a moment. But it is possible for right triangles to have sides that are all integers, but it's not a requirement. And these are called common triples or Pythagorean triples. We'll talk a little bit more about those in a second. Okay? So try these two problems on the bottom of this screen and see if you can find what x and z are for me, please. So in this first problem, x is a leg, so we can still set it up as x squared plus 5 squared, the sum of the squares of the legs is equal to the hypotenuse squared. Now, if you're using your calculators for these, you can use the solve feature on your calculator. Okay. So if you were to type in solve or hit the F2 algebra tab and select solve, enter your equation exactly as it appears, and then a comma x to identify to your calculator what you want it to solve for. It will give you your solutions. Again, it will give you the positive and negative root. You just need to choose the positive of those roots. Now, if you're doing this by hand, you'll have to complete this by expanding out. So 5 squared is 25, 6 squared, 36. Continue to solve for x by isolating the x squared term. So if you subtract a 25 from both sides, you get 11. Extract the square root, you get x is equal to plus or minus root 11. Disregard the negative since it's a length or distance. And so square root 11, you have this irrational number as your answer, which is fine. And remember, entering these online, SQRT, parentheses 11. Okay, and the final example, your unknown is still a leg, so we take the sum of the squares of the legs, so z squared plus 12 squared has to equal 13 squared. Expand out what you have. 12 squared is 144, 13 squared 169. Isolate your variable, subtract a 144 from both sides. you get 25, extract the square root. Once again, you see plus or minus 5 would be your answer. Disregard the negative, so 5. You have, once again, 3 integers. So this would be considered a 5, 12, 13 common triple. Common triples are going to be listed by the set of integers that form the sides.